Okay, welcome to Year 9 Science Online with Any van Vieren. Hey Year 9s, welcome to another lesson, and this time we're going to have a video lesson on the elements. Okay, so please buckle in and we'll get on to the show. Alrighty, so this unit is all about atoms, as we spoke of before. Where's my glasses? I cannot see. Anyways, all about atoms, and remember
And
the Ace of
now,
Science
ASAP Science presents.
song. Due to copyright issues, I cannot play it for you on a video, but you need to know the first 20 elements on the periodic table, what the formula are, and and you need to be able to recognize them. Okay, so we've done this before. We know that everything around us is made of atoms. We know that atoms and matter can be placed into three different states: solids, liquids, and gases. And we learned this during matter. Okay, we know what a pure element is, like pure gold or pure carbon. And we looked at the periodic table, and we talked about how the periodic table is divided into groups: group 1, 2, 3, 4, 5, 6, all the way through to group 18. And we said that how we have the noble gases, because they're so noble, they're so important, they don't want to play with anybody else. So the noble gases do not react with anybody. But then we have the halogens. Hello, halogen. They love to react. And the only thing that loves to react more than the halogens are the alkaline metals. And that's group 1. Okay, so we talked about that. We look at the SLOs. Then we look at the shape of an atom, and we knew that in the nucleus we have protons and neutrons. Those are the things that make up the nucleus of an atom. And the protons and the neutrons do not necessarily have to be the same number. But the atomic number on the periodic table is always, 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 listen to me carefully, the atomic number of the element you're talking about in the periodic table is always, always, always the same as the number of protons. Okay? When you change the number of protons, you change the type of element it is. And then, if it's not an ion, our electrons are the same as the protons because they are balanced. So the atom consists of electrons, protons, and neutrons. And the Bohr shell model, we know that we have a proton, which is the positively proton, positively charged particle in the atom, and then we have electrons, and they are the negatively charged particles in the atom. But we know that electrons are, they're basically considered, for our purposes, we consider them weightless or massless. They have no weight. Okay, so we don't have to worry about them when we look at the mass number or the weight, the molecular mass of our atom. Okay, and then the neutrons, they are neutral. They have no charge. So they are not positive and they are not negative. And then we have these shells, which is like almost a shelf that surrounds the nucleus. Okay, so we have the electron shells. So in this case, when we talk about helium, helium has got the, when we go back to a periodic table, you can see that helium, its atomic number is 2. If its atomic number is 2, we know that it has 2 protons and 2 electrons, unless it's an ion. Okay, so let's count them. How many protons? 1, 2. How many electrons? 1, 2. And in this case, it's got 2 neutrons as well. But the neutrons can sometimes be 1 up or 1 down, but usually it's 1 up. But we'll tell you how to work that out later. So, just so you know, the electrons, it's not a flat thing that is an atom. You need to think about it in 3 dimensions. Can you see how this electron is coming forward? This one is coming forward, but that one is in the plane at the back. It's in a 3-dimensional thing. It's not like this picture where you simply have something on a flat plane. Not at all. It is a 3-dimensional structure, so it's coming forward. Now, have a look at this picture to give you an idea. If you have the nucleus in the middle, your electrons are going all over the place, and they are basically in a cloud around your nucleus. So when we look at atomic and mass numbers in our periodic table, we will see it that it looks like this. So this is C, and C is for carbon. You are expected to know that. But C is atomic number 6. You don't have to memorize that. It will be on the periodic table. And it's got the atomic number 6. Now, what does that number 6 mean? That number 6 means that if it's not an ion, it has 6 protons, always, 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 always. The atomic number is always, 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 always the number of protons. And if it's not an ion, it's got 6 electrons. But down here we have the molecular mass. Okay, the molecular mass. How massive it is. Now the molecular mass of this is 12, so carbon is 12. So if there's 6 protons and 6 electrons, remember electrons are weightless. If there's 6 protons, 6 electrons, how many neutrons? Easy. You take the mass number, that is 12, and you minus the atomic number, that is always, always, always going to be equal to the number of protons. So 12 minus 6 gives me 6. So carbon has 6 protons, 6 neutrons, because 12 minus 6 is 6, and it has 6 electrons. Okay, I hope that makes sense. That is really important that you understand this. Now, when you look at the periodic table, it's made up of pure elements. Alright? There's currently 121 known elements, but we only go up to 118 on the periodic table because the 121 are very new. Okay? And all of them are pure, pure, pure. So if you have gold, that would be pure gold, nothing else with it. It's not like, remember, water is H2O. Here we have H, and if we take 2 of those H's, which is hydrogen, and we add it to 1 O, then we get water. Water is not an element. Water is a molecule, and it's also a compound. Compound means a mixture of 2 different things. 2 or more, actually. So water is H2O, 2 different elements coming together. That makes it a compound. What about sodium chloride? That's table salt, guys. That's the stuff we put on our foods all the time. So sodium and chloride. Is that pure? Yes, it can be pure salt, but it's not necessarily a pure element. That is a compound. So the periodic table, we always put them according to the atomic mass and also the properties, and they're made up of 18 vertical groups and 7 horizontal rows, and the rows we call periods. So if you look at here, we have group 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 18. And this is really important. We'll get to that soon. But when you look at over here, our alkaline metals, they really want to react with water. And I showed you that video of sodium reacting with the water. Whereas our noble gases, they are so noble, you know. We don't like to mix with the other elements. We just don't want to mix, and we call that inert. So the noble gases do not want to mix. They are inert. I've showed you this video, and again, because of copyright, I'm not allowed to show it to you now. So when we talk about the groups, remember, they are the columns. So group 1, group 2, 3, 4, 5, and so forth. That actually talks to the number of electrons that we have in the outer shell. So let's count this one. Can you see that that pattern there is the neutrons and that pattern there is the protons? So let's count the protons, and then we will figure out what element this is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the protons are number 9. That gives it the atomic number, number 9. So when we go up, back to look at this, number 9 is fluorine. Can you see that? Now, fluorine is number 9, and it's got 18.9. Can you see that? So 19 minus 9 gives us 10. Remember, electrons, they weigh nothing, but the protons weigh 1, and the neutrons weigh 1, or their mass is 1. So if we go 19 and we take away 9, how many do we have left? 10. So if I go back now and I count the number of neutrons, they have to be 10. Let's see if I'm right. So when I count the neutrons, remember neutrons are the ones that look like zebras. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yahoo! So 19 minus 9 protons gives me 10 neutrons. And how many electrons? The electrons are the same as the protons unless it's an ion. So you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so now when you look at the outer shell, that means the outer, I want to call it almost like a racetrack or a pathway, but it's called a shell that these electron moves in. When you look at fluorine, fluorine is in group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17. Okay? Now 17, but 7 means there's 7 what's called valence electrons. Valence, that means the electrons in the outer shell. Let's count them. 1, 2, 3, 4, 5, 6, 7. See that? There's 7 of them in the outer shell. So your groups on the periodic table tells you how many electrons in the outer shell. And the only ones we need to worry about is 1, 2, skip a few, 13, 14, 15, 16, 17, 18. 1, 2, skip a few, 13, 14, 15, 16, 17, 18. 1, 2, skip a few, 13, 14, 15, 16, 17, 18. Now, when you look at number 13, 13, how many valence electrons? 3. 14, how many valence electrons? 4. 15, how many valence electrons? 5. 16, how many valence electrons? 6. Easy. 17, how many valence electrons? 7. And 18, 8. Okay, so that's how we're going to remember that. 1, 2, skip a few, 13, 14, 15, 16, 17, 18. So 13 is 3, 14 is 4, 15 is 5, 16 is 6, 17 is 7, and 18 is 8. So, now these shells that they move in, it's almost like orbits. The first two orbits are always filled with only 2 electrons. Now this is aluminium, and aluminium has got 13 protons, and look at its molecular mass, it's 25. So what does 25 take away 13? That is so wrong. Wrong, 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 wrong. Okay, so when we look at this, we know aluminium. Okay, so aluminium, in your first shell, we call these orbits, if you think about them like stuff that's going around in our solar system. These two orbits, the first shell can only take 2 electrons. Okay, but then every shell after that can take 8. So 2, 8, and then another 8. So your first shell, only 2. Your second shell, only 8. Third shell, only 8. And the fourth shell, also 8. I always think about that. The guy who's going to arrive there first is going to be the guy in the 2-seater sports car. Woohoo! Okay, because this is a, a, a ride-sharing club. And the sports car arrives first. So how many seats in this sports car? It's a Polaris. So in this sports car, there's only space for 2. There we go, the first 2. So once they are full, they have to get into my mommy bus. I used to drive a mommy bus for many, many, many years, and my mommy bus can take 8 passengers. So here I come in my mommy bus. I take the next 8 passengers, the next 8 electrons, and when that is full, the next mommy bus has to arrive, and then we take, because we want to save fuel and we want to save the environment. Okay, so 2, 8, 8, 8. Okay, always remember that. 2 is the first one. It can only take 2. Not 3, not 4, only 2. But it can take 1 because 1 is less than 2. The next one is 8. Can it take 7? Yes. Can it take 4? Yes. But can it take 9? No. The moment there's more than 8, it has to bump up to the next mommy bus. And that mommy bus can take 8 again. And in this case, look at it carefully. We have 2 for aluminium, then 8. What is 2 plus 8? It's 10. Now how many in the outer one? 1, 2, 3. See that? So 2 plus 8 is 10, plus 3 is, look at that, 13. Ha ha ha. So how many protons? It's going to have 13 protons. Does that make sense? So over here you can see this is the periodic table that we will give you during the tests. We have group 1 and 2, and then we skip a few. You see all of them have been left out. 1, 2, skip a few. And then we have 13, 14, 15, 16, 17, 18. But I told you that 1 and 2's got 1 valence electron, 2 valence electrons. Valence are in the outer shell, remember. The valence shell is the outer shell. This one has got 3 in the outer shell. Let's go see if that is in group 13. Aluminium, 3. Yeah, haha. 3 electrons in the outer shell. 4, not 14, 4 electrons in the outer shell. 15, 5 electrons in the outer shell. 16, 6 electrons in the outer shell, and then 17 and 18. Now, why is this important? Guys, it's important because for all our chemicals to become stable, they all want to be like the nobles. We all want to be royal, royal. What was that song? We want to be royal. Okay. We all want to be noble. And for you to become noble, and the nobles have 8, that means it's the perfect number is 8. So if you're fluorine and you have 7 electrons in your outer shell, do you want to give away 7 to get rid of that? Or do you want to just take 1? It's a lot easier to take 1, isn't it? Chlorine, if you want, do you want 1 or do you want to give away 7 to get to 8? Because everybody wants to get to 8. But here's sodium. Sodium has got 1 electron. Is it easier for sodium to give away 1 or to gain 7? It's much easier to actually give away 1. So sodium goes, it gives its electron to chlorine. Now sodium goes back up to, woohoo, same as neon. So we have, oh yeah, I'm noble, I'm stable, 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 stable. And the chlorine gains 1, so now it's as stable or as noble as argon. So when sodium and chlorine comes together, sodium becomes really stable, chlorine becomes really stable. Because I have given away my 1 electron, chlorine has taken my 1 electron, and now I have 8 electrons in my ion, so I'm a noble, I'm noble, I'm noble, I'm noble, I'm a royal. Okay, we'll do some more exercises on that, but you need to know that when we look at these numbers, group 1 with 1 electron, 2 with 2 electrons, 13 with 3 electrons, 14 with 4 electrons, 15 with 5 electrons, 16, they all want to end up having 8. Now, if you have 5, do you want 5? Do you want to give away 5 or do you want to take 3? That's the perfect match. Look at that. Okay, so if these two can come together, 16, 6, I have 16, I want 2. Woohoo, I want to mix up with these guys. 17, I need 1, I want to mix up with these guys. You all understand that? Awesome. Okay, so now we need to go and practice drawing these things, and this is called the Bohr shell drawing. So let's have a look at carbon. Okay, so carbon is over here. Whee! There's carbon. And let's zoom in on carbon. So, carbon is in group 14. So how many electrons in the outer shell? Let's count them. 1, 2, 3, and 4. Okay, so there's 4 in our outer shell. What is the molecular, well, the atomic number of carbon is 6. So how many protons? 6. How many electrons? 6 as well. So remember, the outer shell has 4, but the inner shell can only have 2. So that's 2 plus 4 is 6 electrons. But how many neutrons? The neutrons are always the tricky ones. So we take our molecular mass, which is 12, we take away 6, and it's going to give us 6 neutrons. Yay! Alright, so let's do that again. When you look at this picture, how many electrons? We look at the atomic number. How many electrons? 6, yeah. How many protons? 6, because if it was a different number of protons, it would be a different element. Now, how many neutrons? 12 minus 6 is not 12. Wow, sir, you do such amazing math. Your PowerPoint is wrong. What is 12 minus 6? It's 6. So how many neutrons do we have? 6. How many protons do we have? 6. How many electrons do we have? 6. How many electrons do we have in our valence shell? Remember, in your first shell, you can only have 2, but in our outer shell, This is group 14, so in our outer shell we have 4. Okay, so what is 6 minus 2? The first one is 2 because that's the sports car. How many is left? 4. Exactly right. So there we go. Count the neutrons. 1. How many are there? There's 6 neutrons, aren't there? Because 12 minus 6 is not 12. 12 minus 6 is 6. Okay, so 1, 2, 3, 4, 5, 6. Okay. How many protons? Protons are positive. Positive protons. There's going to be 6 of them because that's what the atomic number tells us. 1, 2, 3, 4, 5, 6. Excellent. Now, 14. We want 4 in the outer shell, but there's 6 electrons. So how many in your first shell? Your first shell can only take 2 electrons. There's my first shell. Here's my second shell. Now how many electrons in my first shell? Can only take 2, guys. So 1, 2. Happy with that? Now how many's left? 1, 2, and we need to go up to 6. So there's 4 left. And they will all fit into the next mommy bus, which can take 8. So 1, 2, 3, 4. There we go. There's your drawing. 1, 2, 3, 4 in the outer shell, and 1, 2 in the... So the outer shell is called the valence shell, and your first shell can only take 2. And that is how we draw carbon with the Bohr shell drawing. You are expected to be able to draw all 20 elements like this. Let's try another one. Oh wait, look. Just to show you again. Yeah, it works. Here we have sodium. Sodium loves to explode. I showed you that photo on the pond. Okay. Sodium is in group 1. In group 1, how many electrons in the outer shell? 1. Look at that. 1. There it goes. La 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 la. How many in the first shell? 2. 1, 2. And then how many in the next one? 8. If you wanted to count them, you could. So, let's take that away. How many electrons in sodium? 11 in total, guys. Remember, 1 is for the valence shell, but there's 11 in total. How many protons? The protons have to be the same as the atomic number. So there's 11 protons. How many neutrons? Oh, wow. That's a spectacular mistake there, sir. We take our molecular mass, which is 23 at this stage. Forget about that, please. 23. We take away 11. 23 minus 11 is 23 minus 11 is 12. Okay, because 11 plus 11 is 22. 23, take away 11 is 12. So, how many protons? That's the number you see. Protons, the number you see. 11. How many neutrons? 23, take away 11 gives us 12 neutrons. So how do we draw this thing? We start with the neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now we have to put in the protons. How many protons? It's the number you see. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woohoo! Now we have to do the electrons. And we said it's in group 1. That means it's going to be 1 in the outer valence shell. But our first shell can only take 2, can't it? Our second shell can take 8. And our third shell can take another 8. So, how many in the first shell? 2, sir, because it's a sports car. It can only take 2. 1, and here it comes. 2. Yay! Now, the next one is 8. Because what is 2 plus 8 gives us 10. It's 1 less than 11. Aha. And you said that the outer shell has got 1. That makes sense. So 1 in the outer shell is 1 plus 2, 3, that gives us 3. And then 3 plus 8 gives us 11. Absolutely. Look at it. So 1, 2, 3, 4, 5, 6, 7, 8. Excellent. So 2 plus 8 is, come on guys, this is not difficult. 2 plus 8 is 10. How many electrons do we still need? Only 1, because we're in group 1. Here it comes. There we go. And that's how you draw sodium. Now your homework is to go and draw every single one of them. Okay, up to 20. First thing, you use your stylus. You go hydrogen. How many electrons in hydrogen? 1. How many protons in hydrogen? 1. What is the mass of hydrogen? I don't know. I have to go and look it up. Maybe the last page, look at that, the last page in my SciPad has got a periodic table. Otherwise, you can just go back through the presentation, all the little bubbles, and then you can use this. Okay? It will give you all the information. And lastly, let's get back to the homework. Come on. So I want the number of electrons, I want the mass that you look up, I want the number of protons, and I want the number of neutrons. Okay? And for every single one of the first 20 elements on the periodic table. So so if we look at aluminium and it's 13, how many protons? 13. How many electrons? 13. How many neutrons? I don't know, we need to go and check the mass. Magnesium, how many protons? 12. Sulfur, how many electrons? 12. How many protons? Oh, why do I say 12? Sorry. Electrons, how many electrons in sulfur? 16. How many protons? 16. How many neutrons? I don't know. What's the mass? Because we take the mass, we subtract the number of protons, and that will give us the number of neutrons. Mass minus protons gives us neutrons. Mass minus protons gives us neutrons. Okay guys, so please complete that for me, and tomorrow we'll work a little bit further on this. Have a great day. Thank you. Bye.